I'm Vilius. So previous two presentations were more about regulation or about the concept, or you have to be a lawyer maybe, or some kind of an officer to understand what was said. Or so what for example, is if you're having a coffee somewhere here, not so far away, in a coffee shop on a beanbag, and thinking, oh, let's do a breakthrough and make a world a better place with a fintech of our brand new idea. So, and you probably want to host the technology, in the corner of your old laptop, but probably would go on the cloud. So, is it hard to make a secure fintech on the cloud? And yeah, not very. So that was the presentation. So, of course, as usually with cybersecurity, we do like asterisks a lot. So with reasonable amount of knowledge and consistency. And as Martinos already mentioned in the first part, he's yet to meet a secure system. So, and that's usually true. I guess Miroslavas later on will expand on that further too. But usually people lack on the consistency part. There are lots of knowledgeable and smart and really great people around, but I guess the consistency usually is where people are lacking. So yeah, so I'm Vilius. I'm at Komponent, a security architect. So I spent almost all my life next to technology and actually being helped to implement the product, or as some saying goes, where the rubber meets the road. So that's hence that quote that I put here, we will address security issues next sprint. That's probably the backbone where all those problems happen. Security tasks are hard to implement, or so they think so. That's usually is, they are not prioritized over features, because feature is something that and the customer sees, and security feature or secure feature is just, why bother that? Let's do a next sprint, because right now we have something burning, we have styling to fix or something else. So yeah, so I'm gonna share with you a few tips that you can do right now, or okay, not right now, but probably tomorrow morning, and see how can you make your own financial institution or not financial institution probably better, what to do with the cloud. So you don't probably want to be LastPass, if you heard already. So it was a good password manager from the beginning, then it wasn't. So, for example, many people talk about compliances, right? So how many compliances do you think LastPass had? And the answer is all of them. All of SOX, all of ISOs, and whatnot. So if you visit, LastPass today and you go to security, which is obviously appalling, but they do have all those stickers that you probably need, and you would ask all the white papers and all, and they probably meet all of those, but suddenly they're not good anymore. So probably there is something lacking in those compliances, or maybe people who do those compliances probably don't look at the right places. So anyway, what you can do, not to be like LastPass. Okay, so there will be 5 tips, really short. So there will be a summary at the end, so you don't need to make up photos or anything, but you can ask questions later on. So access from infrastructure from a trusted source IP. So let's say you're building a startup or have a company here in Lithuania, and you probably have a few people around in your office, and that office has an IP address that you can trust. So why not put that IP address in the actually access list, that only those IPs can access your infrastructure? So for example, that policy on the right is really easy to implement. You create a condition saying that all of those IPs are allowed, and if an IP address that comes not in that list, you just basically deny anything. You put your people on the cloud in a few groups, and then basically apply those policies for those groups. Don't forget the vendors integrations. So let's say you're a fintech and you need to communicate with, with the regulators, with VMI, for example. You put their IP address there. You put somebody else's address there. You perform a KYC with another partner. You put their IP address there. You just don't trust the whole internet. Basically, pinpoint the exact sources who might be permitted to access that part, and then you cut, like, I don't know, 90+% problems. So, of course, there's one kind of caveat to that. There are plenty of other resources on the cloud that you could specify exact place, source IP address, who can connect. So let's say you have a developer in your team and he needs to access the development environment from his home because he wants to work late in the afternoon and not to bother and go to the office, so that person creates his own rule saying that, okay, I will access this resource from my home IP address. And you don't even maybe know this, that this rule happened. So how to overcome this and how to monitor it, I'm going to go with the other tips from my presentation, but basically you have to keep an eye on those specific definitions from what those locations are that people are actually accessing that. Yeah, forcing 2FA. So that comes as a no-brainer, I suppose. So kind of, it's already a standard, everyone should use 2FA and all of that. But to actually use it and to actually enable, it's better to put a forced setting. So let's say let's help with the policies. So again, I'm taking this as an AWS policy, but Azure can do the same. Google Cloud can do the same too. So basically, you're saying in the policy that if you have MFA as a false, you deny everything on all of the resources. So then a person comes along, he logs in, he's a new joiner, he created his account yesterday, and today he needs to go to the cloud. And then he comes in, he says, I didn't see anything. And then you can remind him, have you enabled MFA? And then, oh yeah, I forgot. Then he enables it, and then he sees it, everything. So, because if you don't have a process how to guide person into those correct patterns, usually they don't happen. So it's better to create those narrow paths that going out of them would be hard. So for example, in this case, if person doesn't have MFA, he just doesn't see anything on the cloud. I wrote here there will be a pushback. So let's say with the cloud we interact with the APIs or with the methods from command line. So the 2FA tokens will be asked, and that's really, really not convenient. So there will be someone from development team coming along and says, hey, this is really stopping us. And then you can say, sorry, but that's the protocol, deal with that. And that's that. But disabling it isn't a good idea. It's always better to have it. Okay, split environment for production development. So this is not so obvious, I suppose, but it's really a prevalent problem for a small company. So let's say you created your first version of production or first version of staging, just to see how everything looks. And you keep everything in one place because it's really easy to fire up, to set up, to have everything on the same screen. But then your product grows and it becomes bigger and more features, and the database becomes larger and all of that. But now you find yourself that you have a production database, a staging database, or development database, and everything is in the same bucket. And now suddenly, if the staging environment is compromised, then it's not that difficult to jump from one environment to the other because those resources are just close by. So it's usually a good idea is to just split them from initially, saying that, okay, this is going to be a separate account, like separate room. This is for the testing and a separate room for the production. And everyone's happy from that point because anything happens on the testing part, if it blows up or somebody leaks out their credentials, and now they can then the whole internet can access your staging account, that's still okay because your production data is safe. We heard already what happens if you just leak out somebody's personal data. So that's probably not a good idea. So don't keep your customers' personal data on the test, and keep everything on the prod, and keep those separated. You'll be fine. Having this kind of a setup as a tree usually helps with the managing. So you can keep an eye what's happening, how many accounts you have, and all of that. But more importantly, you can monitor them centrally, not to log in into every account or every subscription as would be in the Azure part. Who is attacking your staging, or who is attacking your production, or who is attacking your other environment, you can just monitor it centrally and it will be fine. I think all of the cloud providers have some kind of a idea like this. So AWS would look like this. Azure could be done like this with different tools, but the idea is the same. You have just different environments for different purposes. So have as much infrastructure as a code. So this is the magic word which says DevOps. So a person can do everything on the cloud by themselves, by hand, and that is good to start. But when the company reaches a certain maturity, which is probably, from a technological point of view, is probably in the first 6 months, it would be best to transfer all of that setup as a code. And we do have some kind of magic word to say Terraform, which is probably known for you already. There's Pulumi, another great tool. So stay away from ClickOps. We say ClickOps because that's usually somebody and clicking by hand. And it's really easy to miss something doing by hand. And it's really easy to see all those problems when they're written as a code. Especially for a developer, it would go around and all of the platform, it would be done by code. So the scanning is way better, way faster. The answer times for those security scanners will be way faster. So having them as a code would go a long way, and I would suggest everyone do that. If you have resources or can spend a little bit of overhead of time to actually go that. So in reality, if done with the code, so nobody needs to actually have an admin rights on the cloud. Anyone can have read-only. So those problems in the beginning that I mentioned, those just can go away because nobody needs to log in and change something on the cloud. You can do everything with the code. So some kind of worker logs into the cloud and just makes all the changes. And the last one, central secret management. So this is again not something of a breakthrough. So you have a place where you keep your variables or the tokens, secrets or some kind of parameters, and you refer to them as variables in your code or in your platform. Stay away from hard coding values. So all of the tokens that VMI would give you, or the certificates that given you by Sodra to you, or some kind of a secrets that central bank would give you, all of those should be put in some version of secret management. So that could be a cloud provider or native. So AWS has this, Azure has this, but there are also products. I don't want to name them, but the idea is that there is like huge array of ways how to store them centrally. The idea is that somebody needs to do that and store them centrally and not to hard code secrets into the code, which then can be leaked and then read by somebody else. So, yes. Yeah, so the hard coding values is really something that not to look forward to. If you kind of think about your own product and know that you have hard-coded values somewhere, you know about this, so please fix this. It will be better for everyone. And I think that was, so this solved the 5 points in one slide. You can take this picture if you want. But so basically, if you're accessing infrastructure from a trusted source, you force everyone for the 2FA, you split environments for production and development, and have it as a code. and you can manage your secrets centrally, you can pretty much be sure that you're safer than, I don't know, more than 80% of companies around you, because most of those things are not implemented in most of the companies. So yes, so please do that. We'll be safer on the internet and we'll feel better. So thanks.